Okay, what's up everybody? So I saw a video floating around on YouTube as well as Facebook comparing the standard algorithm to the area model method when multiplying. And the point the video was trying to make was that this method, the standard algorithm, is much faster and easier, and this method, the area model method, is much more difficult, has way too many steps, and takes a long time to complete. I did both of these using both methods side by side, and it took me around the same amount of time. Both methods work. Both methods can be very useful and easy to do. It just depends on what works best for that scholar. Parents and sometimes teachers are still trying to drill the standard algorithm only because that's how we learned it. We don't want to take the time out to understand this method or understand why this method is beneficial or even unpack all of the questions that students have and recognize that we sometimes fall short on explaining the steps in this method, and that's why they're really confused. So when teaching this, or when we're solving a problem like this, we set it up in this way, right? Stack them on top of each other, and then we start to multiply 3 times 7. Well, the first question I'll always get is, why do we start off with the 3? Why don't we start off with the 6? Well, when we get over that hump and realize that we have to start in the ones place, in the tens, in the hundreds, and like place value, and we multiply 3 times 7, well, we put the 2 up here and we put the 1 down there. And the second question I always get is, why are we splitting up the numbers? Why do we split up 21 and put it like this? What's happening when we do that is that we put the 1 in the ones place, so that's where it falls, and then we put the 2, we regroup the 2 in the tens place. So then we multiply 3 times 5, which is that 5 is in the tens place, and then we add our 2 tens that we had to regroup, and then that's how we got 17. But like I said before, that's a mouthful to explain, right? So imagine a second grader, a third grader, a fourth grader trying to understand that. That's a lot, and it's really difficult. So they have trouble duplicating that step. The other question that I get is, when we move on to the 6, why do we add the 0 down here, right? Well, again, if you don't know how to explain that, you might be saying something like, well, this is just how it's done, and that's how you get the right answer. What we're really doing is we're actually multiplying 60, not just 6. We're multiplying 60 times 57. And if you get your calculators out, 60 times 57 gives us what we have in this second row here, 3,420, right? And so that's where that 0 comes from. It's 60 times 57. And we also know that when we move over to the 6, we multiply 6 times 7, we have to regroup 4 in the tens place as well, right? Students oftentimes confuse the 2 and the 4, and then they don't know which one to add, or they forget to do that. They forget to add the 0. If we have 3-digit numbers, then we have to add a third row and add 2 zeros, so they may forget to do that. So there's a lot of room for confusion and mistakes in this method. In the area model method, I really like this method because what we're doing is we are expanding the numbers, and then we're multiplying each component and then adding them up at the end. Making it simple, we have 57 times 63. Well, expanding it, 57. And then I have 63. And then I multiply each component and put them in the corresponding box. And then I add them up at the end. That method is so simple, it's so easy. And what I love about this is that it makes the numbers really easy to work with as well. They're dealing with 1-digit numbers like 3 and 7, the basic math facts. And then you're dealing with tens and hundreds. And if you teach your students or your kids how to multiply tens and hundreds and thousands when dealing with zeros, this method is perfect for them because it's so simple. You multiply your leading numbers, 6 and 5, which is 30, and then how many zeros did I have? 2, so now I have 3,000. 6 times 7 is 42. How many zeros did I have? 1, so 420. 5 times 3 is 15. How many zeros did I have? 1, so 150, right? And then 3 times 7 is 21. It's really easy to work with tens, hundreds, and thousands, or in all those zeros. You can do the same thing with 3 digits. You can do the same thing with 4-digit numbers, 2-digit numbers, 1-digit numbers. You can do this method with anything. And I think it's very beneficial to learn, especially if your kids are struggling over here. Again, I did both methods side by side on Black's Theme Instagram and Black's Theme YouTube. It really takes the same amount of time. So it just depends on that scholar. I hope you're able to find something out of this and see the benefit in it, don't just drill one way. If this way doesn't work, don't allow for your student, your child to be frustrated. Try another method and see how that works out for you.